Hello everyone. Uh, Welcome you all in this new module course, that is Advanced Python Tools for DFT Simulations in Siesta, and we will deal with that ASE and Pymatgen and sisl type tools under the banner of this CIAN, and this is Siesta Innovation and Application Network. I am Mohan L. Verma. Actually, that DFT people, we already learned about, know about that DFT and related to that Siesta also especially. So we just moving for the automation of the calculation, and for the automation purpose and workflow, that Python, it's very good language. So we can use different Python tools to automate our computation. And for that, this course is being introduced for that 24 hours, and definitely this will be very interesting course. And I'm Dr. Mohan Verma, so you should know about myself. So I have 25 years of the teaching experience, teaching as well as research and academic leadership experience. And I am a material scientist, and also I'm working with that nanomaterials and computational physics. So my work is now integrated with that DFT, density functional theory, and I am using Siesta and transistor type tools, which are free of cost. And also I have some experimental work working in this lab, and have stabilized advanced research facilities in central India, and this including computational nanomaterials research lab, and supervised more than 15 PhD scholars and so many PG scholars in theoretical and experimental domains. So my research focuses on structure, electronic, optical, magnetic, transport properties. So I have just touched almost all the properties of that DFT using Siesta, and for that device fabrication. I collaborate with the scientists worldwide, and have published extensively in peer-reviewed journals, contributed book chapters, and have some secured funded projects, and also filed multiple patents. So far I have 125 research articles in reputed journals, and I am passionate about training the next generation of researcher. So people actually know me about my training, different training sessions in workshops, and as well as my previous courses. So this is one new type of course, new module with 4 modules. So far I have trained about more than 450 students worldwide, not only Indian but also from different countries. And definitely that most of training is an online mode, and this is also that online course to help people. So the course objective, one thing that is the master Python scripting for system integration. So we will begin with that the basic lectures of Python, because not this is fully focused on Python programming. Some glimpse of that Python we are going to use in this system integration tools. So we will utilize that ASE and that Pymatgen for the structure generation, and then we will apply this sisl for comprehensive output analysis. So that Siesta generates so many output files, and we can analysis that this all these output files by using SIS tool. So then definitely this is for the automated advanced curriculum workflow, and we execute independent capstone research project, and definitely this is Python based, so that will be easy to learn, and the flow will be smooth. Target audience, definitely all my courses, these are for not only the graduate but also graduate, postgraduate students, and the previous Siesta and the transistor user, because the prerequisite by this course is that you must at least have fundamentals of DFT as well as that Siesta, because I'm not going to deal any DFT based lecture, include in DFT based lecture here. So you must at least know about what is actually DFT is and how Siesta works. Then you can work with this particular Python tools. And that research professional, we are aware of that some basics of that Python, and they can use this Siesta, and it's related Python tools for industrial RD applications and high throughput computational screening. So this definitely this course is for to study electronic structure backgrounds and other and people can use this for their research project and make the things easy using Python. Complete training structure. So definitely all this training structure is classified into 24 sessions, that is 24 hours course, and divided into 4 modules. Include that 12 theory lectures of about 40 to 45 minutes, and then these 12 hands-on lectures, and duration is 4 weeks, and this will include 45 to 1 hour discussion session, which is actually we generally planned in between 6:30 to 7:30 IST. So you will be the part of that, and you can discuss about your issues during the learning of this Siesta and other Python based tools. So final project and certification. So after giving some self-assessed statement test and other things, you will be able to get some good projects as well as e-certificates. Course overview. So this is the 4 module course, 3 lectures and 3 hands-on session per module. So we will begin with that electronic structure manipulation by using that ASE tools, and then electronic structure analysis, and then this optical properties characterization, and some quantum transport properties also. For that sisl is especially designed for analysis of that data obtained from that Siesta as well as the transistor. And then the first module that this will include that Python basics and the Siesta input output. So we will begin with this Python for scientific computing with this NumPy, pandas, and this input output operations with Siesta formats and data cleaning and pre-processing techniques. So we will begin with this first lecture, and then some visualization basics, that matplot, live fundamentals and advanced plotting, so Seaborn and statistical visualization, custom plot scripting and formatting, interactive visualization techniques, and then I will introduce in the third lecture that sisl. This is one good library and structure. So and we will include that core concepts and the structure of this library, reading and parsing system output formats, and basic band structure, dust plotting, integration with different Python libraries. So definitely that hands-on session will include the terms related to all these 3 lectures. So that from the Python basics to Siesta input output formatting. In the second module, that lecture number 4, that ASE fundamentals, we are going to learn that the building molecular and structure, surface generation, manipulation, coordinate transformation, input file formations, and then these Pymatgens for advanced operations like crystallographic symmetry operations. These are the terms in solid physics, and supercells and unit cell transformation, material database integration, defects and dopant incorporation. So these are the terms we use in material research. And then definitely that workflow automation is the prime objective of this course. So that the strategies of this workflow automation, it will be included in lecture 6. So this Python automation techniques, batch job management, error handling, discovery, and result and database management. And then the post processing utilities, that is sisl based utilities. So this is some advanced level utility which is from raw data to physical insight. So we will study about that band structure analysis by using this sisl, that high symmetry k-points generation, band structure, electronic. So these are the terms, of fundamental terms used in DFT system, not only system but other tools also, and people should know about all this. So lectures 8, that will focus on DOS and optical properties, and lecture 9, transport properties with the transistor, and definitely this that hands-on session will be included, will include all the terms, Python based terms related to all these 3 lectures. Now the final, this module, that is module number 4. So this is for research excellence, scaling up innovation. So high throughput material screening, lecture 10, and then this machine learning integration. I will try to include here what is that machine learning, how that Python can be used to this, and then this capstone project development by using this Python based workflow. I'm going to give in final lecture number 12. So this automated screen setup, machine learning, data collection, analysis, and project comparison, all these things will be in the concluding sessions. So tools and software. So this definitely, as I mentioned that this Python based tools like ASE, Pymatgen, Python material genomics, and SISL, Siesta analysis library, and then this NumPy, Panda, Matplotlib, Seaborns, and scikit-learns. These are the terms we are going to learn in this course. So this also that computational visualization tools we have Siesta, Transista, Vista, XCrystal. So these are the terms we previously used, but also I will try to give some fundamentals of this and compare that results with that visualization with these tools available. Assessment, so that the Python coding SISL is 30%, and the workflow automation task that will be 30%, and then some mini project 40%. You will get e-certificate after completion of this course. So expected outcome, so I promise you will be master of this Python and SIL with SISL integration. So this automated parsing of multiple system output files. So you will enjoy this learning by automating your workflow using Python and Python based tools integrated with Siesta, and also some advanced transistor output file analysis, and develop customized research workflow. So you will be able to design some good scripts after this course, I promise. So, and also I promise that you will be happy to learn. Anyway, so be the part of this amazing course, and definitely I promise you will enjoy various requirement with me. So the details of this that fees, registration fees, and other things that is given in that description part of this lecture, and also that different contents you will get from that website.